the Parthenon, a nautilus shell, and the Pepsi logo. What do these seemingly unrelated things all have in common? They're all linked together by a particular number called the golden ratio.
The golden ratio is the irrational number 1 plus the square root of 5 divided by 2, often denoted by the Greek letter phi, which is approximately equal to 1.618. The golden ratio has always existed in the natural world, such as in nature, in space, and in the weather, but we are still unsure of exactly when it was discovered and intentionally used by humans. The first recorded definition of the golden ratio comes from Euclid's Elements in about 300 BC, where he states, "A straight line is said to have been cut in extreme and mean ratio when, as the whole line is to the greater segment, so is the greater to the lesser." Euclid is referring to the division of a line at the 0.618 point on the line, the golden ratio. Jumping to the 1500s, the ratio is given its first name, the divine proportion, in Luca Pacioli's book, De Divina Proportion, and continued to grow in popularity with artists during the Renaissance. Also during this century, we see the German mathematician Simon Jacob discover that consecutive Fibonacci numbers converge to the golden ratio, and the first known decimal approximation of the inverse golden ratio from Michael Masterlin of about 0.618. In the 1700s, we see the mathematicians de Moivre, Bernoulli, and Euler develop a golden ratio-based formula to evaluate Fibonacci numbers based on their place in the Fibonacci sequence. In the 1800s, Binet rediscovered this formula, and it was named after him. The 1800s are also when the ratio finally received the name golden ratio from Martin Ohm, and finally in the 1900s, the golden ratio is designated the Greek letter phi to represent it by Mark Barr.
The golden ratio is the only number satisfying that golden property phi squared equals phi plus 1. This is nicely illustrated in this grid overlaid with squares. Geometrically, the golden ratio represents a division of a line or area such that the ratio of the bigger piece to the smaller piece is the ratio of the whole thing to the bigger piece. In other words, this split needs to follow the formula bigger plus smaller divided by bigger equals bigger over smaller. When this is solved, bigger over smaller ends up being the golden ratio. The golden ratio is also closely related to the progression of Fibonacci numbers. The Fibonacci sequence starts with two ones and then adds the previous two numbers recursively, as you see here. The quotient of consecutive Fibonacci numbers converges to the golden ratio. For example, the 17th Fibonacci number divided by the 16th is about 1.618034, which is also very close. Binet's formula, seen here, generalizes this to solve for any Fibonacci number. There are many other interesting occurrences of the golden ratio in other sequences and geometry.
The golden ratio is important because it can be found in many different aspects of our world, both artificial and natural. The golden ratio can appear in several different forms, such as the golden rectangle, golden spiral, and the golden triangle. People use the golden ratio all the time to enhance aesthetics. One instance of this is in architecture. For example, the United Nations building in New York makes use of golden rectangles. Another great example is the Parthenon in Athens. The ratio of the width to the height of the temple, as well as the ratio of the height of the temple to the height of the columns, closely follows the golden ratio. The golden ratio can also be found in things like logo and product design to be more attractive to the customers. Many of the most famous logos you probably know of use the golden ratio in one way or another, such as Pepsi, Twitter, and National Geographic. Some commonly used products like laptops and credit cards have linked with ratios close to the golden ratio. The golden ratio also occurs everywhere in nature. Spiral galaxies observed in outer space closely resemble golden spiral patterns. Many horned animals have spiral-shaped horns that tend towards the golden spiral. When leaves form spiral patterns around a stem, the rotational angle between each leaf is approximately 360 degrees, divided by the golden ratio. Scientists have even found instances of the golden ratio in the most unlikely places. The aspect ratios of proteins are approximately equal to the golden ratio, and the golden ratio can even be used to predict bond lengths between different atoms.
As we have discussed, the golden ratio is a very special number. For thousands of years, humans have been examining and making use of this number, and even today we continue to discover new applications and appearances of the golden ratio. As you walk around in your day-to-day life, examine your surroundings and you'll definitely find the golden ratio.